And welcome everybody to the Daily Space Weather video. This one's dedicated to my granddad. Please keep him in your prayers. He's 93 and he knows a lot about things like heliophysics. You might be surprised. Here's some very specific wavelengths of the sun. Some massive plasma filaments down here. And we are about to switch to a coronal mass ejection watch. So we now have a coronal mass ejection watch in effect. We've also got filaments up here that are quite visible in this wavelength from the Solar Dynamics Observatory. Here's the colorized magnetogram. So solar activity quite low here actually, just 2 sunspots, quite similar, quite stable, and quite simple in their fields. Nothing too exciting going on, likelihood of major flares not there. Radio flux only at, I think, 82. And just a little side note, if you want to make the kind of videos that we regularly show on the channel, check out helioviewer.org. It's spectacular. Here's the radio flux on a 1-year chart. Again, only 82 for the radio flux. Here's a space weather enthusiast dashboard. And there is some geomagnetic unrest forecasted late in the day tomorrow and early in the day on the 21st. By the way, we'll be putting out some great lunar eclipse time-lapse imagery later today, most likely. We've got a couple different videos in the production pipeline. Looking at global seismicity here, the 7 magnitude earthquake drought continues. The largest quake of the past 24 was a 6.2 at Papua New Guinea. The SMASH team would have already known about it at smashamash.com/SMASH team, links below the video. And I didn't see any tsunami alerts associated with that. Let's go to the USGS list. So some quakes here. In the middle of the US, we did cover a 4.0 in Missouri yesterday. Some quakes in Western South America. Let's just scroll up the list here. That Papua New Guinea quake happened at 14:08 yesterday. That's 14:08 Universal Time. Or right around noontime in the eastern U.S. Chile saw a deep quake. So a couple of deep quakes happening there. And there's an aftershock at Papua New Guinea, I believe. 5.4 aftershock. And keep in mind, folks, any of these quakes could be foreshocks. Because remember, there's a 7 magnitude earthquake drought going on. So there's a 5.8 in Central America there at Guatemala. Japan saw a 5.0. So a bit of a seismic uptick there. There's a deep quake near Tonga at a 4.5 magnitude, nearly 500 kilometers for that one, 480 the estimated depth of that quake. A 5.2 near Panama. So will the 7 magnitude earthquake drought end sooner or later? Let us know in the comments what you think. Check it out. It's a real estate investor's dream. Sort of. Assuming you don't have structures built in the lava flow path. This is on La Palma. An estimated 12 hectares of new real estate was created. Spectacular imagery here from volcanodiscovery.com. They had to upstage Hawaii with 12 new hectares. Anyway, La Palma continuing to explode here. Again, lots of lava flows. 8,000-foot ash plume coming out of the caldera. Please don't pole vault it. So the tremor activity is falling. That's probably a good thing. Let's check out the rest of the most recent volcanic eruptions. Oh, check it out. Yowzers. Spectacular imagery here from InVolcan's Twitter account. I may have to follow that one. And don't forget to follow me on Twitter If you're not on Twitter, get on Twitter. I mean, you might not like the stuff that goes on there in terms of censorship, but just don't get banned. That's the trick. We have over 8,000 tweets on the Twitter page, most of it exclusive. It's twitter.com/smAshoMash. We're all over the internet at smAshoMash. I've been using the name in multiplayer gaming since 1999. Yes, that's where it came from. Originally, it appeared in Special Ops 2 Green Berets, smAshoMash. Originally a gaming name. Karimsky is also erupting. Kamchatka. No indication of the size of the ash plume. Sakurajima flight level 080, that's an 8,000-foot ash plume. Mount Ibu, 6,000-foot ash plume over Halmahera, Indonesia. Semeru exploding, 14,000-foot ash plume over East Java. Kilauea now making it back on the list. The lava lake surface has been descending here. Now, lowest of the, what is this? The lava lake surface is now at the level with the lowest of the dropped blocks remaining from the 2018 summit collapse event. All right. So lava lake falling at Kilauea. Katmai has stopped erupting abruptly. Nevado del Ruiz, 20,000-foot ash plume over Colombia as Nevado del Ruiz explodes. Revenador exploding in the country of Ecuador. 15,000-foot ash plume from there. Sabancaya in Peru, 25,000-foot ash plume as Sabancaya explodes. Volcanic uptick, folks. Nevados de Chilean exploding. 13,000-foot ash plume from Nevados de Chilean. That's located in central Chile. And Piton de la Fournaise on the Isle of Réunion. A seismic crisis. Yowzers, popular vacation spot, La Réunion. "42 volcano tectonic earthquakes, no significant ground deformation detected," meaning magma arriving into system, likely balanced by the magma being erupted as lava. The reservoir continues to pressurize, and the process may last several days to weeks before it breaks through the surface along a new section. So yeah, a crack in the earth could open up with lava coming out of it at Piton de la Fournaise on the Isle of Réunion. So don't pole vault the caldera. Don't pole vault lava fissures in general. Do visit the links below the channel. Check out our designs. They're spectacular. They could make anybody angry or delighted. Who knows? Today's featured product is... And by the way, we have this Fauci fraud one on a bath mat. If you'd like to put your feet on Fauci's face every day when you get out of the shower, check out the Fauci fraud bath mat. But today's featured product is the Universum Liberate. So here are all these things. We've got all kinds of spiral notebooks and water bottles and so on. Again, they make great gifts. To quote Rush, "If I could wave my magic wand, I'd set everybody free." So Universum Liberate, folks. That's today's message. And today's featured product. There's the higher res design. It's quite good. You can find links to the merch shop at the homepage, smAshoMash.com. We need your assistance for these videos to continue to exist, much less remain publicly visible, and so on. So please tell your friends and foes about us. Press the share button. Share on Facebook, as Meta really likes us. We have nothing but positive things to say about Meta in hoping that it goes out of existence. So here's the GOES magnetometer over the past 3 days. Hopefully the metaverse won't cancel the GOES 16 or GOES 17, right? Just kidding, folks. Social media has not been known to ban any satellites. There was an ArcJet moment here. That's when the satellites have to turn on their thrusters, which creates plasma, which could affect the readings of the GOES 16. It's the GOES 16 that had to adjust its orbit there. And here's the polarity of the heliospheric current sheet. Earth remaining in a South Pole one, shown in red. Nothing to write home about here. it's pretty uneventful. Here's the line of sight view, which is not animated for some reason. Let's try that again. There you go. There's the line of sight plot. No North Pole current sheet in our near future here, it looks like. Here's the coronal hole plot. We do have coronal holes in our future. That's why the Space Weather Enthusiast dashboard is expecting some geomagnetic unrest. It's from these South Pole-oriented coronal holes down here in red. So two named sunspot groups. Here's your coronal hole imagery, by the way. This is 193 angstroms from the SDO, one of our HelioViewer movies. And that southern coronal hole quite well defined there. Likelihood of flares, not high. They're both alpha-class sunspots and have remained largely unchanged over the past 24 hours. Here's the flaring profile of the past 3 days. Just a couple B-class intensifications over the past 48 hours. No proton strikes, no surprises to our regular viewers. Here's a real-time solar wind. By the way, this is measured at Lagrangian 0.1, if you're wondering. So this isn't right at Earth. The ACE and the Discover are located at Lagrange 0.1. More about Lagrange points in a moment. Current solar wind speed 465 kilometers a second. Solar wind density 5.25 protons per cubic centimeter. KP index at 1, pegged over the past 24 hours. Excuse me. So over the past 27 hours there, KP of 1, geomagnetic calm conditions. Here is a visual model of the likely scenario going on around planet Earth right now. It's the magnetohydrodynamic pressure modeled by the Space Weather Modeling Framework over the past 4 hours. That's a mouthful. Please leave a comment if you watch YouTube channels that use big words to try to sound intelligent. Homogeneous pressure over the past 4 hours. And look at Earth's ground magnetic perturbations here, changes to Earth's own B field. Nothing real weird going on. If you weren't aware, by the way, Earth's southern magnetic pole is down here. The north magnetic pole is up here. There's a weak spot over here and a slightly smaller weak spot over here. Again, pretty homogeneous magnetic flux density over the past 4 hours. And here is the solar system view. We'll advance this a week. There's your solar system forecast. It's a gibbous waning. So yeah, there's the Discover, located at Lagrange 0.1. We're going to look at Lagrange 0.1 and Lagrange 0.5 here, the location of stereo A. And for you new viewers, these are gravitational equilibrium points. So this is where stereo B is located. Here's stereo A. Here's the Discover and the ACE. And of course, out here at Lagrange 0.3, where we can't see anything, that's where Nibiru is located, if you're wondering where Nibiru is. That's the location of Nibiru. Pardon my sarcasm. Next, a star chart, and there's a partial lunar eclipse just mopping up at the moment. This is what the situation looks like in Lehigh Valley, Pennsylvania at the moment. The moon is moving into a setting mode and coming out of Earth's shadow. Anyway, here's the view from stereo A and the Soho-Lascaux C3. So there's 2 coronagraphs for you. And this coronal mass ejection is growing increasingly likely. It will eject at least part of this plasma right here. At least part of that will eject into the greater solar system. Some of it might collapse back onto the sun. And we're expecting to see a giant prominence as well as a CME coming basically at any moment. So let's do a brief cosmology segment. Once again, today's is integrated to the daily space weather video. Check our playlists. There are over 200 cosmology segments on our playlists. You may be amazed at some of the weird stuff going on in space. Here's one of the weird things going on in space. It's certainly multispectral imagery. of a nebular cloud surrounding what looks like a globular cluster. So this one's probably located in the Milky Way galaxy. And we're just doing a little slow crawl here. We'll show a full screen version as well. Just spectacular imagery there. Probably looking at infrared and visible and X-ray. Those purple portions are probably X-ray. We may even be looking at some radio imagery there. Anyway, there's the full screen image of that. And that is known as NGC 281 from the new General Catalog. And I'll put the caption on here for a minute. Located about 10,000 light years away there in the Milky Way galaxy. So yeah, infrared data, some Chandra X-ray data there. And the star cluster is known as IC 1590 if you want to look at it. Go look up IC 1590. It's spectacular. And you can go look at it yourself at apod.nasa.gov if you like. Today's random, quote, random, end quote. Is anything really random, folks? 927 is this entry. Entry number 927, Quasar B2008-159. These are the hard X-rays over the past 16 years and the past 30 days and the past day. That's the upper left. Here's 16 years and here is 30 days. A fairly consistent X-ray source. And just to give you some background as to how we get these images, we click on SMBAD, which takes us to this page. So what we're doing here, just so you understand, folks, is we're starting out at the Neil Gehrels Swift Bat X-ray Observatory. And we're picking entry number 927. And then you click SMBAD. That'll take you to this. And then you click the CDS portal, which takes you to this page. And this is where you can get all the spectral analysis and so on. All kinds of articles about it, when articles were written. It's quite spectacular. And the reason that we look at a quote random end quote object every day is because there's a lot of stuff to look at. And getting plausible theories as to how all of these things are doing what they appear to be doing is what cosmology is all about. So you can see on this quasar in particular, quite a few papers written around 2008. Perhaps not a coincidence that it has 2008 in its designation. You can see it's bright across most of the spectrum, but there's a dead spot right in here in between like 40 and 1,000 angstroms. So that's interesting. And let's take a look at this in some varied spectra. This is going to be visible light from the DSS. Let's take a look at it in X-ray. And we're really finding surprisingly incomplete X-ray imagery of this one. Not exactly sure what's up with that. There you can see a bit of a bright spot in X-ray frequencies. Let's see what we get in ultraviolet. And there's a little additional clarity perhaps. And it is a pretty decent ultraviolet light source, that quasar. Here's the region in optical wavelengths from pan-stars. That's bands Z and G. Nice close-up of that quasar for you. And last but not least, we'll show it in thermal spectra. There it is in infrared light. It's quasar B2008-159. QSO B2008-159. That's our featured cosmic object. Our other featured cosmic object is the moon. And we'll be putting out a video probably later today with some time-lapse imagery of that. That's today's cosmology segment. Let's blast through a little more data here. Charging hazards are non-existent. Electron flux is at moderate levels. Here's a 3-day chart from the GOES 16 and 17. Forecast is for flat levels by NOAA. I have no arguments about that. Next, we're going to show you the total electron content forecast. And here it is. in all of its full animated glory, showing you the electron density of the inner Van Allen belt. Anyway, once again, we're seeing likely GPS errors over North America here, even at nighttime. There you can see some pretty high levels of electron flux. We'll also show the ionosphere. The F ionosphere layer is located at about 300 kilometers of altitude. And let's just get those maps going. There's the ionogram. Certainly some low frequency anomalies around the North Pole region. Here's the anomalygram. Also some low frequency anomalies around South America. And the South American continent is itself indeed a portion of the magnetic anomaly on the planet Earth. The weakest point in the entire magnetosphere is right about there. The South Atlantic anomaly, maybe it should be renamed to the South American anomaly. Anyway, there's the latest image on the ionogram. That's 10:30 Universal Time. There's the latest image on the anomalygram showing you anomaly in megahertz from the 30-day median. By the way, if you don't view our meteorology segments, check them out. They usually premiere before the daily space weather. It's time to chew bubblegum and do bonus features, and I'm all out of bubblegum. So here's the ground-based solar observatory at Cerro Tololo in Chile. And these filaments that we're talking about that are going to erupt are right about here. That's why we put up a coronal mass ejection watch. It's going to turn into a warning probably promptly. As they're slowly making their way around here, there's also filaments up here. So expect to see some fireworks coming soon. Next, the latest intensitygram. We're going to press refresh so you see it happen. So there's the intensitygram. This sunspot has degraded further. This one has remained mostly stable. There are the magnetic fields. Nothing to write home about there. We'll close out the video with a composite view, but first the GOES 16 SUVI. Eye on those filaments. We'll stream it on the Twitch channel throughout the day today, and we'll probably capture additional fantastic footage. It looks like our dual wavelengths here are getting out of sync toward the end of the video. You're not hallucinating that, folks. That's really doing that. It's because the synchronization between 171 angstroms and 94 angstroms is not there. So we're getting that weird-looking effect. Missing data from one of the wavelengths probably is to blame for that. Anyway, thanks again for tuning in. May that solar wind be at your back. Opinions expressed in this video are not necessarily the opinions of Smash News Network, least busted, name and news.